So feelings are mental experiences of the state of life in an organism. Feelings reflect the effectiveness or lack thereof of homeostasis, translated in terms of pleasantness or unpleasantness, pleasure or displeasure, flourishing or pain. And so this is extremely important because with living creatures, and certainly with us, because we can report on our feelings, what we describe in terms of our feelings, the description of the valence of a feeling, is in fact quite directly correlated with the success or lack of success of our homeostatic process. It has a direction that is predictable, so you are in states of pleasant feeling or in states of unpleasant feeling when our homeostasis is deviating in the good direction of flourishing or in the bad direction that leads to malaise, disease, and death. So it's not that you have feelings of pleasantness when you want to, you have feelings of pleasantness or of pain when the conditions of the organism are such that you will end up having a disruption of homeostasis and go on towards sickness, or have an upgrading of homeostasis and go on to flourishing. The correlation is perfect. The other thing is that the very phenomenology of feeling describes in very direct ways what is happening to our own physiology. And what it is describing in the end is the state of a number of chemical pathways in operation, generally operating on a number of viscera that are very easily translated in the feeling itself. So you're talking about the constriction or the dilatation of tubular viscera that have a wrapping of smooth muscle around them. You're describing what happens to them, say whether it is the trachea or whether it is one of the tubes that is part of our gut or our esophagus. You're describing what happens to smooth musculature in the vessels that are throughout the body, and quite particularly in the largest of our viscous, which is actually the skin. And all that is happening, which is part of a coordinated operation to run life the way it should be run, is being portrayed, and I'm using the word portrayal on purpose. It's a multidimensional imaging of that process in all of these components of a system that has numerous points. And a lot of that is being built out of a cooperation between that organism, that fundamental organism that happens to be alive, and the nervous system, which has a central component, but lots of peripheral components that can in fact collect the information, bring it over a series of stations to central points, and deal with this absolutely magnificent act of cooperation between nervous structures and non-nervous structures. And this happens because we have an organism that has a nervous system that serves the organism and not the other way around. This is something that, with all of our tremendous hubris over being neurologists and neuroscientists and cognitive scientists, we sometimes think that the brain actually runs things. Well, the brain doesn't really. The brain is a servant of an organism that is alive, and without a very general and generally operating system such as the brain, we cannot do much at our level of complexity and multicellularity. But the fact is that you have to put the things in the right proportion. Nervous systems serve the organism. Organisms permit the nervous system for obvious reasons, because it's a cooperative and very advantageous arrangement. So this cooperation is essential, but this cooperation is so tied to the reality of that particular organism, to the description of the components that are showing up in our mental panorama, that to think that they are not linked And of course, I don't have any problem with the idea that they're being operated and constructed by algorithmic arrangements. But to think that those algorithms would not be related to the structure that they are operating on, I think is a pretty difficult idea to accept. By the way, I would make an important exception here to say the following. I don't have any problem with the idea that you can design machines, obviously not using a carbon base, but whatever is convenient from the point of view of engineering. You can design machines that would be perfectly capable of being organized the way our feeling systems are organized and could represent in the equivalent of a mental space something like feelings. The point, though, is that those feelings, although they would formally be like our feelings, would not be felt by that machine, in case the machine could ever feel, would not be felt with the same description that our feelings have. So it's really a question of what feelings are describing, and feelings are describing in humans for certain, and we have no reason to believe that in animals they do anything different. They are describing the state of life. And that is not divorceable from the substrate on which it is operating. With enormous respect for creatures that are non-humans, even with all the love that I have for dogs and other smart creatures, I do not expect a dog to confronted with sudden pain or with sudden pleasure, to place that moment of pleasure or pain in the context of huge past life and events, and even less in the context of the anticipated future life and events. Now, this is absolutely critical because we do all the time. And much as I used to have the position that human feeling is going to be like feelings of any other species, I've come to the conclusion that I don't think that's the case. Now, of course, it is in the basic mechanics of it. It is in the basic process, in the sources. In fact, it's even remarkably similar in terms of the molecules that are used to operate it. When you look at the different mediators or different molecules, take, for example, the whole suite of opioid molecules and opioid receptors. All of this is present in extremely simple creatures. This is not a human discovery. So we have plenty of reason to argue that lots of those creatures are going to have operations of feeling that are probably very comparable to ours. But among many other subtle differences, I don't think that they're ever going to place the feeling in this context of past memory, past events that may have to do with your personal history, with the story of your family or the place where you have lived most of your life, and even less with the projection into the future. This is something that I like to call, and we have called it actually in many occasions, memories of the future. We are constantly making memories of the future. We're constantly making predictions of what we're going to do tonight and tomorrow and in summer, who we're going to be with, how our lives and careers are going to sail forth. Now, all of that planning that is constantly going on in the form of a very complex narrative is being committed to memory. You cannot have something bad happen to you without automatically thinking about the consequences of that something bad or potential consequences in terms of your future. So this, I think, is a very, very critical, a very critical distinction. And then we can even go lower and go to more basic biological levels and find human distinction. For example, a critical part of the hippocampus, which is, of course, absolutely essential for all this process of memory that we're talking about, and I'm talking now about the dentate gyrus, is very important and largely mammalian evolutionary development. And it is especially complex in humans. So first of all, it's something that is fundamentally mammalian, and then it has huge expansion in humans. And the kind of making of memory that we do in relation to a unique event, for example, if I'm going to remember being here, and many of you and you remember being here and hearing me, all of that which is unique, it is not a general category of events. It is also a general category of events. It's a conference done by a guy that is talking in front of an audience. But it is also a specific event that has to do with the specific program and the time at which it took place and where it inserts in all of this narrative. All of that can only be achieved in humans if you have this structure called the hippocampus, and if you have within the hippocampus this structure called the dentate gyrus. Without it, you're never going to lock it in. You will experience it, you may have a vague remembrance of it, but you will never have a considerable build-up of details out of which you could recall that memory in the future, which is, of course, the purpose of having memory in the first place. So, not only is that structure especially evolved in humans, but it also happens to be the beneficiary of something which was not known until relatively recently, which is neurogenesis. There are new neurons that are being formed and incorporated into that structure, and they're not there just floating. They actually become part of circuitry, and they are critical in order to build new memories. And that neurogenesis is extremely abundant in this region and extremely abundant in humans, and is also tied very much with astrocytes, which happen to be part of the process of generating it, and which also happen to be especially abundant in humans. So you have literally boxes and boxes, or Chinese dolls if you want, of slight specializations and slight increases of sophistication in the structure, out of which you then can have something very big explode as a result of so many particularities.